Hello. Can everybody hear me? I'm assuming so. Microphone looks correct. Alright. Well, hello everybody. Music levels seem adequate. Okay. Hey everybody. How's it going? I'm Paul. I am a coach at Major League Hacking. That's my kind of side job. My day job, I'm a grad student at Arizona State University. I work on a bunch of different NASA missions, so I regularly work at NASA. Over at NASA JPL specifically, and Goddard Space Flight Center, I guess. And today we'll be doing a stream on Taipy where I will be building some fun things, but then also some things that I actually need for my own research and work. So when I saw that this was an available stream for me to work on, I was like, this is actually perfect because Taipy is super useful for looking through data, analyzing your data, and overall just like a good time to work with. So let me pull that banner down. Everyone having a good Thursday? I don't know what time zones. It might be Wednesday where you are. I don't know. Or it's not Thursday, Friday. Well, let's get started. So, I had in mind 3 different projects that I wanted to kind of play around with. Let me share my screen. Alright. Let's do... Does that work? Oh boy. I'll do that. That works. There's some coffee here. Nice little cappuccino. So, I had 3 different projects that I had in mind that I wanted to use Taipy for. And we're gonna list them out here, and we're gonna try to knock out as many of them as we can, because why not? Let's have fun with it. Plates versus bowls. So, I was meeting with some of my friends from my undergrad last night, and we had a very long discussion about plates versus bowls, and like what is the threshold between when a plate is no longer a plate and when it's a bowl. There's been a trend going around recently a little bit about plates that look like bowls. So plates that look like bowls, and you find like all these people posting like, you know, plates that look like bowls that look like plates, or bowls that look like plates that look like bowls. Like whole TikToks obsessed about, you know, finding these plates that are optimally plate shaped and bowl shaped. And all of us that I was meeting with were all scientists, and we're all kind of sitting around thinking like, at what point does a plate no longer become a plate? And how do we define plate versus bowl? Because there's like pasta bowls and pasta plates. And so one of the ideas for a project that we were going to put together, and this is directly related to my research, I promise, is creating a tool that you look at an image, and then you can make the distinction whether or not it's a plate or a bowl. And we record all that data so that way we can have a catalog of, here are plates that we think are plates, and here are bowls that we think are bowls, and here are blates, which is what I've heard people call these, that we're not really too sure about. And this directly ties to a lot of the stuff that I work with, where I'm looking at data and I need to make a decision on, is this a cosmic ray in my detector? And I figured instead of looking at very, very dull images of raw detector data, we are going to look at plates and bowls, because I think that's going to be a little bit more fun, and hopefully we can have some hot takes on whether or not some of the images I picked out are bowls or plates. The next thing that I wanted to look at is looking for aliens on Mars. And by aliens, I mean just things that we didn't expect to find, not actual aliens. Although who knows? Maybe we find actual aliens on Mars. You never know. Mars image viewer. And this would be kind of an extension of the plates versus bowls, because what we can do there is we can then have a bunch of different things that we're looking at in the Mars images, and maybe label the images as we collect them. So it'll be a good way of looking through the images, and then also the Mars images are just kind of fun to look with, and I have a big data set of Mars images for us to play around with and check out. And then finally, this one's going to be a little bit more in depth, and I'm going to be spending the majority of my time on this one. It'll be a hyperspectral image analyzer. There we go. Analyzer. If you're not familiar with hyperspectral images, I'll explain them very briefly once we get to that part. But the idea is creating an interactive tool and using Taipy as a GUI that will let us interact with our data and better analyze it. So, with that, let's begin. Any questions? Any comments, ideas, thoughts, feelings? I know it's kind of a quiet morning after the holidays. I'm just sipping along. All right. Well, with that, let's open up a new project here. I'm gonna chuck that in a new tab. Let's go here. I'm gonna zoom in a bit. And let's make a new file. Let's call this plates.py. All right, so before we begin, why don't I pull up the MLH tutorial on Taipy. hack.mlh.io usually gets you all the good things you need, everything you need to know. hack.mlh.io. I'm gonna click on software here. And then the very first one after circle is Taipy. And they even have your first application with Taipy tutorial. So that's super useful. Why don't we go through that so we can get, everything squared away. So we have a main.py and a CSS, main.css. Let's just very quickly run through this tutorial so that way we make sure everything's set up properly. We're gonna make both of those. We need to install Taipy. I'm going to install it in a new environment. Yeah, let's do that. Just so that way my Python libraries don't get all messy. All right. I can remove the plates for now. We don't need that yet. We're going to go through that tutorial first. Let me zoom in a little bit. Okay, and it looks like it's pretty simple. Hello world. Okay, so looks like we just run this, so let's run it. No module named Taipy, that's because I'm not using the right library. Conda activate Taipy, and now we run it. It's a lowercase t Taipy, isn't it? Oh boy. Oh, I made the environment and I never installed Taipy, did I? Silly me. Slowly installing everything. Well, while it's working, why don't we read through what it does? So, we have the Taipy GUI. It's gonna be running on some port, and on top of that, we're gonna give it a page. And so this should give us a nice and pretty hello world file. So let's actually run this now. Oh boy. Oh, that's why. Why is my... Did I not conda activate Taipy? One moment while I debug. Oh boy. So what I'm trying to do right now is I'm trying to set up a conda environment that has I don't know why. It usually doesn't happen to me. Oh, wait, no. You know, we're just gonna try this. Gonna be honest, I have no idea why that kind of environment wasn't working for me, which is lovely to see. But we're gonna use my astronomy kind of environment because it already has everything installed for me to run the astronomy things I need later. So we'll do that. Yeah. All right, and now we can Python main.py. It probably is a lowercase t Taipy, isn't it? Well, the tutorial seems to be missing something, but never fear. We'll go straight to the documentation here. Actually, not even the documentation. The GitHub has a little bit more information. And import Taipy as TP. That's probably the easiest way to do that. Ah, that's why. At some point, it appears that at some point my environment did something weird and my pip is all messed up. That's something fun that I get to fix later. But for the time being, we'll make sure that we'll just do this another way. Oh boy. Today is going to be me playing with Python issues, isn't it? I sure hope not. Alright. Not entirely certain why it's breaking like that. I think it has something to do with me setting a Python. I'm not going to worry about it. It's fine. Everything is fine. Oh boy. Hello, hello. How are you doing? We're watching Paul's failed Python installation doing strange things. And now we're installing Taipy. That's all probably fine. Yep, totally fine. Everything is fine there. Okay, so now back to what we were trying to do. Python main. Hey, we have a server running. Let's go look at it. We got a little server here. It says hello world. How do you make an environment for Python? Great question. I use Anaconda. So I have Conda installed on my computer. If you don't have Conda installed, you just go Conda install. And you go install one of these things using the different operating system instructions. And then what you do, you go conda create name, and then you name your environment something. So I named it Taipy. And then assuming your Python installation isn't all messy like mine is, when you do conda activate Taipy, you'll get like a little thing here if you have some stuff on your environment set up, or it might show up like as Taipy and then your path. But the idea then is whatever. The idea then is your Python will be linked to Taipy instead of linked to instead of linked to your base installation of Taipy or of Python. And so that way you can kind of manage all your different libraries, and you're not just installing all of your libraries to one giant monolithic Python installation on your computer. Very useful for when you have a bunch of different projects that you were trying to work on. All right, so in the meantime, we have made a little hello world. It is cute and cuddly. Let's see if there's anything else in this tutorial. I'm going to make some notes about the tutorial that I'll let everyone know, let them know, because there's a couple issues with it. All right. So the kind of crux of Taipy, what makes it tick, if you will, is doing neat stuff like this, where you define your page here by their own sort of markup language, and then you can render that page using their GUI. So if we go back here and we look at the Taipy app, refresh the screen here, you can see it's our very first Taipy application. And we got all that there. We can make some changes to this. It's kind of like Markdown, so I could be like, this is part 1, and then I can say section 2. This is part 2. And then if I go back this way, this is part 1, this is part 2. And just like that, you've built a website, just defining a little bit of text. It takes like 2 lines of code, really. You got a page definition and then a run. And it makes it super easy to do that, to make it like a nice static site. But we don't just want to make something static. We want to make something that changes and has fun as we play through it. So, if you weren't here from the start, we have 3 different project ideas. One where we talk about plates versus bowls, which is the one we're going to start off with first, where I complain about how plates are taking over the world. These are plates that look like bowls and bowls that look like plates, and they infuriate me because where does the line drawn? What is the difference between a plate and a bowl? And to fix this conundrum, we're going to build a little application that shows a bunch of images. And I picked up a ton of them. Let's delete that one. Of plate bowls, bowl plates, platey bowls, and we're going to have users come through and choose whether or not they think that this is a bowl or a plate. It's a very simple application, but it will be a fun one nonetheless. So, first thing I want to do is I want to get all of these images in a nice readable format really quickly. So as you can see, a lot of these are just like WebP, this is a JPEG, they're all sort of different things. And so we're gonna find something that will load up these images. I believe Pillow is a library that we can use for this. Pillow is an imaging library and it lets us load an image pretty quickly. So why don't we use it? I believe I already have it installed, but if I don't, it doesn't hurt to check. No, I do not have it installed, so now I gotta do the weird thing. Pillow. I apparently do already have installed. That's neat. Let's go to the installation handbook here and just using the image class from pill. That's why I couldn't figure it out. Pill import. So if we're going to use it, how do we generate a requirements.txt? Great question. So with Conda, you could, so typically you can use Conda as your package manager. So you can do Conda install this file, Conda, or instead of pip install. I typically use Conda just to make the environment and then still use pip for everything. So you still do a pip freeze requirements.txt, and that will spit out a requirements.txt of all your requirements. Because my pip is being weird, I need to do it this way. Here's a bunch of my requirements, a lot of lots and lots of mess. But you can also, if you want to use Conda as your package manager, there is a Conda freeze thing. So it's Conda list, I believe, is how it works. Yeah, Conda list. And that spits out all of the stuff that you have currently working in your Conda. There is also a Conda export, which will create a YAML file. So if I do this, it generates a nice and clean YAML file, which tells, this is the name of the environment. These are the things installed. These are the channels that it's getting its libraries from. And here are all the dependencies, including my pip dependencies. So it actually runs the pip requirements through this. So if you want to complete requirements.txt, you get this. Yeah, great question. So we need images. So I would like to load up one of these images. So let's, pick our favorite here. That seems like a nice plate. And let's load it up. So this should be able to load the image, and we can verify that real quick. So I am a researcher by trade. I code occasionally. So I often end up testing things in like a Jupyter notebook, but I'm trying to stray away from that today just because I feel like that's not necessarily a good way of doing things. I don't know. It's still a way of doing things. But I find that it's a little bit messy. So we're gonna test things just in good old command line. All right, so we have our image open. And now we want to put it in our page. So why don't we head on over to the Taipy documentation, which is located, Taipy cloud documentation. That's not what we want. We want, might be in the getting started guide, knowledge base. All right, cool. Under image, alrighty. We just have to pass it content. Okay, so it looks like all we have to do is just do content image, and then it'll display an image on our app. So why don't we give that a shot? And I think I need to reload this. Let's do it here. Didn't like that. Probably because we opened the image. So why don't we try... Yeah, it doesn't like it being this JPEG image file, which is fine. We can just give it the image path. Is that... And we'll place an image path there and see if that keeps it happy. I'm keeping the image stuff here because we eventually want to be able to use Pillow for this, just because it'll make our lives a little bit easier in the future. And let's refresh the page here. And boom, we have a bowl. Or is it a plate? I would call that a bowl. Can zoom out a little bit. We're zoomed way in right now. So, one of the things that I want to play around with here, and I'll do that by dragging you into here, so that way we can have both of these things next to each other. Alrighty. And we can hide you for now, I think. Nope. Let's drag you down. One of the things I want to play around with is, apparently in Taipy, you can put your CSS and everything here. So I forget how you do it. I think styling. No, styling. There it is. Style kit. Inline style kit. So I can define some styles for it. So I might be able to say, I think I can just do like width equals 50%. Does that work? No. I will find it. Style kit provides CSS style kit. I want the example that they have in Python here. Inside the container. I mean, I know I could do this with like actually CSS, but inline style makes it a little bit easier because I feel, oh, you know, we can just do this with equals 100 pixels. Force them all to be squares. Oh, the way I'm missing a line at the end. It's important to read. Hey, now we have a tiny little square there. And we can make that 1,000 by 1,000 if we really want to. For a big old square, or a big old square of bowl. There we go. Bowl square. All right. well, we'll do 100 by 100. No, 250 by 250. Just to keep things nice and simple. All right, and we're gonna call this bowls or plates. Bowls or plates. So we have an image of a bowl or a plate. And now we would like to create a couple buttons so that users can click on and play with. So let's go over to the notes here. Let's type in button, and I'll zoom in a little bit. I realize it's a little hard to find. And if we scroll down to the bottom, we can see that it's pretty easy to just grab one of these buttons. And we'll start with this button. Button label. And button. So we just gotta put some words here. We can say that this is a bowl button, and we'll put a plate button next to it. Bowl plate. I want these on a new line. Let's do that. And I could center all this and play with the CSS, but I don't think you're here to watch me futz around with CSS. Unless you are. I don't know, maybe that's your thing. You like watching people may play around with CSS all day. Could be. I thought that would work. I'm not a CSS wizard, despite what people may tell you. So now we have a button here for bowl, a button here for plate. And they both kind of do some fun things here. But let's kind of clean some stuff up here. So I'm going to have this pick a random bowl or plate image as we go along. So we're going to create a new thing, get image, and we're going to have a little random number generator. I forget how you get a random number in Python. It's import random. And then it's random dot rand range 0 2, and then we're going to have a bunch of images, so we're going to import glob as well. Glob lets you define a path and get stuff from that path, so we're going to clean up some stuff here. Glob, and this is we're going to call this images equals glob. We're going to actually image paths. Glob. And we're going to say that this is going to look at the, what do I call the directory? Images. Okay. Images star. And that'll give me everything in the images file directory. So this will give me a random number between 0 and the length of paths. And then we're going to return paths n, which will give us a image path. So now path equals get image paths, image paths. We'll have that there. We'll have that there. We'll put path in that. And now, if we're lucky, and I did things right, when I refresh the page, it gets us a nice little bowl. And in theory, every time I resave this, it should give me a new one. Yes, it does. But now we want to actually have it give us a new image every time the page gets reloaded, or when one of these buttons get pressed. So why don't we try the latter here when one of these buttons get pressed. So these buttons all have listeners on them. Listener is a function that gets called whenever a whenever something occurs. So in our case, we're going to have listeners on these buttons. So when the button gets pressed, it's going to trigger this action. And we're going to have two actions, one called bowl pressed and one called plate pressed. We could probably simplify it into one action, but we're going to be verbose here just for funsies. So state is currently the state of the site. So we're going to do state dot I forget how we do this. We need to label things. That's right. Now I remember. So by giving it a label, I'm actually going to double check something real quick. I believe it's a label. And if not, then I'll pull up the tutorial I was looking at earlier and we can go from there. Ooh, it's upset with me. Why are we upset today? No. So I saved something and it got mad at me. No, label is literally the label. That's not what we want. We would like to be able to check something here. So one moment while I go find this video that I was looking at earlier. It's as simple as state.path, because we call it path here. And we can then, let's just make either of these buttons refresh the image. So. Let's try you now. So when I click on bowl or plate, you can see this shuffles us through all of the images of bowls and plates and all of that nonsense. And all we have to do was take our state and use the variable we have here. So why don't we rename this to image path just to make it a little bit clearer for us which image we're actually updating. So. Now I'll refresh the page. No, it doesn't like that because we call it image path. Yeah. Yep. Alrighty. So, now that we're collecting all of this information, we can now... Ooh, some of these images are actually not the size we want. Maybe I define what the width is and then let the height speak for itself. Yeah, I think that's a cleaner way of doing it. Actually, maybe the other way around. So that way everything's not bumping up and down. Seems reasonable to me. Now finally, we want to be able to save all this information somewhere. So we're going to keep things pretty simple here. We're just going to make a little CSV that's going to get updated every time we do this. CSV dot. I always forget how to. One moment. It's like CSV writer. Let's just call this out file equals open. And I know that this is not exactly how you want to be doing this, but boldplate.csv, right. All right, we're going to do that. So now, when we get when one of these buttons is pressed, we can do writer.write row. And we can, in that row, put two pieces of information. What was the image path that we were at? And was it a bowl or a plate? And so now we have a nice little way of keeping track of all of our classifications. So let's rerun this. It's gonna yell at me for something because I probably did something wrong. Yeah, it doesn't like me. What else is new? So now we have our bowl plate.csv. I'm gonna click on bowl here. I'm gonna click plate, bowl, plate, bowl, plate, plate. And if we look at this file now, oh, is it not? Ooh. Why is it not working? I'm not sure why this is not working. Should just take the image path from the state, chuck it in a bowl. I mean, I probably should do this a more clean way where I actually like with file open, with open this, probably put it in append mode, have a writer, and then that writer writes the thing. So that'll actually open and close the file, because that's probably the issue. The file's probably staying open, and that's why it's upset with me. Let's take a look now. Bowl. That would do it. Bowl. Oh. Bowl. There we go. That does it now. So now we have our CSV where we have the file name and the bowl. In plates, and you can see it does now we can actually, if we wanted to, we could go through and actually start looking at these. So like, I would call these plates, probably, maybe. Those are definitely plates. Showing us those plates again. Those feel like plates. It's hard to tell with like how the image is a little skewed. But I'm gonna go with probably... I think there's more bowls. Call it a plate. Plates, bowls. Plates, bowls, plates, bowl. And now you can see we're collecting all this data here. So we can actually go through and learn something about the data. But I think that we've had enough plates and bowls for the time being. Why don't we have a little bit of fun with something not plate or bowl related? So I'm going to go ahead and clear some of this out here. Don't actually need this. And we're gonna make a different file to play with, where we're gonna basically take the same thing, but create a little bit more of an interesting data set with it. I need to unzip this real quick. I have grabbed a bunch of really fun data from a project I used to work on. And we're gonna unzip test novel. Yeah. So we have a nice data set of wonderful little, let me clean up here, of images from Mastcam, which is one of the cameras on the Curiosity rover. It's also, there is a new one on the Perseverance rover, but I don't have those images with me, easily accessible. We can look at what some of those images look like. I'm just going to open up a Jupyter Lab instance. We're doing this the Paul way of playing with things. In fact, I can show a different way of doing this. All right, let's get some NumPy and PyPlot. np.load, and we're going to load mcam. Mcam test novel. Let's just load one of these arrays. So one of these images is 64 by 64 by 6 because they are multispectral images. How Mastcam works is it is a camera on Mars that has a bunch of different little filters. So it's got its traditional like Bayer pattern that you would expect in like your phone, that sort of stuff. But it shoots each of its images through this color wheel, and that color wheel rotates, and the idea is then you can take a multispectral image by taking your image through a green, image through a blue filter, image through an orange, image through a red filter, image through a purple filter, etc. And when you put those all together, you get a multispectral image. So you would get an image that looks like this, and it gives you the ability to then actually view your data, which is pretty neat. One of the things that we're going to do is we're going to start looking at some of these images. I need to remember very quickly which order these images are in. Let me pull up where I got the data. From an old Zenodo. Oh, okay, it does not like me. Not like me today. Not the right data set, but I believe if I go here to version 2, this is the right data set. And do we list the order? We don't, but I can just make some assumptions. I believe the first 3 are R, G, and B. Yeah. There we go. That's not quite right. I know it's the first 3. 0, 1, 2. And then if I do... Oh boy. Can I do like a 3, 1, 2? 3, 2, 1. Oh wait, it would be 0, 3, 1. 0, 1, 2. 0. One of these combinations is the correct combination to actually see these images. There we go. That looks more like Mars to me. It's 2, 1, 0. All right. So we have these images here that are that show Mars in all of its beauty. You can look at a couple different ones here. Oops. It's a drill hole. And why don't we, instead of having these images that are just from the internet, JPEGs and that sort of stuff, why don't we load in some NumPy arrays into our system here? So I'm going to go ahead and make a duplicate of this because I'll post these later. And we're just going to call this one Blates for bull plates. And let's try a new way of doing this. So we're going to need NumPy. We're going to need Glove. We're still going to need our CSV. We'll probably need random. Don't think we'll need pillow anymore, but we never know. And let's make our new image paths these, which will be all of our images. We might need some bold pressed stuff, but for the time being, we can worry about that. We can comment that out. And the reason I'm showing it this way is that way you can see how you could adapt these projects for something completely different. So before we're, making is it a bowl or is it a plate? But now we can take that base project and do something very, very different. So why don't we do that? Okay. I'm now going to go to Google Taipy image with NumPy array. Convert a NumPy array to an image. Alrighty. And I'm gonna, in the quotation marks, put Taipy. Because I know that there's a way to do this. So right now I'm just looking for a way to display the image data using Taipy. Because I believe that there's I've seen it done before where you can kind of embed a matplotlib anything? Taipy numpy. Well, I've been going for almost an hour or so. So what I'm going to do is I'm going to take a short 5-minute break, look up this, keep the music going, and be back when I figure that out and maybe get some water. But in the meantime, feel free to tell me what your favorite Mars image is, if you have one. Let me go pull up my favorite website to look at these. Atlas, Pegasus Image Atlas. I always like looking through the Image Atlas just because they have so much cool stuff. They even have a beta of the new one here. But we can look at the Mars 2020 images. These are from the newest mission. And let's look at CamZ. Now, Mastcam has some weird images. Let's... That's the landing cam. Well, anyway, I'll put this link in chat if you want to tell me your favorite image from it. Maybe you can find some cool stuff in it. But I will be back in a couple minutes just to get some water and look into that. Alrighty. Sorry, I'm trying to find the buttons. Alright, be right back. Hello, hello. Welcome back. My kitty was outside my door crying because I was streaming and not paying attention to her. And so, here's Peanut Butter. Say hello, everybody, Peanut Butter. She is so mad right now. Alright, I'll let you go, baby. She will be joining us, maybe, or be leaving immediately. Goodbye. Alright, so I figured out what was up with the image stuff, so I'm going to go ahead and share my screen again. What we needed to do is we need to convert the image to a bytes array first. So, we do need pillow. I was right about that. And yeah, let's go ahead and do that. We're gonna change up the get image here. So we're gonna pick a random image. Load paths n. So this is gonna load up a random path. We're gonna get the data for that. We're then gonna need to convert that data to a bytes image. So I've played around with some code here to get that. And this converts everything to an image byte. So now we can do image bytes. I'm just gonna call it image. Make our lives a little bit easier. Image. Let's see if that does everything that we want it to. Let me just close it and restart so that way I can get that going. So anybody find a favorite image from the array? May as well. Asking image analysis. All right. So now what we can go ahead is we can then start looking through them. I'm going to bring back some of the functionality of these buttons here. We're going to call this weird. We're going to change these buttons to strange and not strange. Strange rest. Not strange press. So we've played with it, and now we've retrofitted it a bit. Now we just gotta do a couple of things. Image. And finally, we refresh the page here. That seems like a pretty boring image, not strange. Image path is not defined. Oh no. Image path is not defined. Oh, yeah. Ooh, that's important. We don't actually have a way of keeping track of what image this is. So why don't we play with this a little bit more? Instead of this having return get image, it'll be path and image. And we return paths n as well as the image. So it'll give us what the image is as well as where it is. We'll then chuck a little thing here that just says what the image is. So it's going to be I'm going to put the path underneath it. Actually, we'll do it this way. I like it more. Make the label a path. So now we want state path, state.path. And then when we update this thing, we'll do path, path, path. There we go. And let's see if that works. I don't know if it's gonna work. For all I know, it could break on me. But that's okay. It's got a label, I hit strange. It's got a new label, I hit strange. Yep, works perfectly. And as you can see, oh, not plate bowls anymore. We have our masked cam file. You can see we're collecting data on whether or not these things are strange or normal. That's a strange one. That's not strange. Not strange. Not strange. Pretty strange. And just like that, we've retrofitted this to not take images anymore, but take NumPy data, which is kind of like images, kind of like not. But showing all that sorts of stuff. Ooh, I have my banner still open, don't I? Let's take that down. All right, so now on to the more, I wouldn't say interesting, but more nuanced way of doing this. Something a little bit more akin to my research. So I do astrophysics work, and oftentimes I am looking at astrophysics data, which is usually in the form of big cubes that are hard to parse and play with. So why don't I go find one of those cubes? We're gonna hop out of my MLH folder real quick, and we're gonna go into my science folder. So, ooh, where is it? And more importantly, what am I allowed to show people? I think science here. One of these should be my fits file. One moment while we're gonna open up a new instance of Jupyter Lab here, and I'm going to test something. Let's do that. Why not? So I don't have the spectral cubes because I think I lost those in a terrible fire. No. Something, but I do have something else for us to play with. I'm currently just loading up which data set is the most fun to show. probably the Oberst data set. All right. Just bear with me for a moment as I pull up my data. Alrighty. So, what I have, and I'm going to pull up the paper here for a brief second here. Looking at papers. Is this what you expected to do today? Looking at papers? This is what I do all day. It's fun. It's actually not that paper. Dang it. Well, we're going to be looking at the Carina Nebula, which I'll just pull up the Wikipedia on it. Carina Nebula is this gorgeous nebula located in the sky. That's how these things work. We actually just got some beautiful photos taken of it from James Webb. So if you've seen this image from James Webb, this is the nebula that we're talking about. And we're looking at Eta Carina. And that's at least part of my research, which I believe is like right around here-ish. It's been a little bit since I've worked with this data set. But in the meantime, we're gonna load up some of this data and kind of work through ways to play with it. So, first things first, we're going to pull up a couple things here, and I'm going to make a brand new file here. We're not going to retrofit, but we might steal some stuff from it. Spectral.py. We'll call it spectral. And we'll get some astrophysics stuff going, and I'm just going to make this a whole window here. So if you're not familiar with FITS, FITS is a file that that's mostly used in astronomy, but it lets you define like your coordinates and that sort of stuff. And we're going to create a file viewer for FITS files in Taipy. So let me grab an example FITS files from one of these examples. AstroPy example FITS file. Example multi-spec. Let me just pull one up here. Reading and plotting in image. Yeah, that's what we want. This is exactly what we want. All right. Let's see if this works for me. And we can clear some of this stuff out. We don't actually need any of these tests in there. All right. Cool. All right, that did work. So now we have the file. And let's load it into a spectral cube. So import spectral cube as sc. Sc.l. Let me pull up the spectral cube documentation because it's literally been a while. I'm going to do it this way. Here. There. This one actually has the WCS installed on it. Perfect. All right. So, let's build a tool to play with this thing. It's a little bit of a small shape. I'm gonna actually try to find the a different one. Also just got a ping. Who would be pinging me? No. Sorry, I thought I had the right file installed, but I didn't. So now we get to play with this for a moment. Apologies. Do I want the fits? No. Yes. This is what I need. Well, either way, we'll do it this way. So we get our cube here. We can do cube dot a quick look, I believe. It's not fun. It's not a very fun cube. Other examples. Please give me a good data file here. Sorry about this. Again, I'm just not finding a fun file. The one that I have is a lot bigger, but I don't think it's on this computer, which is a shame because it should be in the directory that I had it in. But boy. Oh. We'll work with this file. It's a little simple of a file. It's not as fun as the other one, because in the other one you can actually see some of the really cool tendrils of the nebula. But this is an example file. And you know what, we'll green nebula fits multispectral. Let's pull up this. Do we have the... That's the original. I want the fits. Image fits. Will it give me the fits? Nope. Astronomy. Spectral. I just want a dummy sample fits files. There we go. This is what I'm looking for. Primary dedication for is Yes, this is. Let's pull up this Hubble Space Demoscope image here. Let's go projects, MLH, Taipy, and save. Okay, now we have something to play with. Yep, there it is. Copy, path. Should be a fits file. Yes, it is. Okay, cool. So if I read this in here, it should cause me no problems whatsoever, and it should be great. Of course it's not. Okay, whatever. We're going to do it with the example image, because I don't want to waste any more of y'all's time. Okay, so we have our image here. We have our image cube. So this cube has 3 dimensions in it. It has an X and a Y direction, as well as a V direction, or S, depending on what you want, which is basically the distance from the target. So you have your points in the sky, your RA and deck, and your velocity. And with these, we can make pretty images using Taipy. So from Taipy, import GUI. We're going to pull up our old code to the side here, so that way it's easy for us to reference things that we need. And let's make our page. So we're going to call this spectral cube analysis tool. Now we are going to go ahead and try and get a very simple version of this running, where we just show an image. So we're going to need to do a little bit of the image prep stuff that we did previously, where we take our data array and turn it into a bytes array. So our cube is loaded. We're just going to pull the first frame, so that would be this 0. And we're going to create an image array from that. Let's actually look at the data. 0, we want that, 0. All right, so our numbers are very small. So let's normalize our cube. So we're gonna go cube.max. Does cube.max work? It should work. Oh, my music has stopped playing. I just realized that. All right, let's get another nice and comfy mix of music going. Jazzy holiday music. All right, let's go. All right. Can I do cube over cube.max? Yes, I can. Alrighty. So we have data in the form of a spectral cube. We need to normalize that data so that way the data is somewhat reasonable to work with. So we're going to divide it by the maximum. We're then going to create a array of array here, and we're going to do all of that to make sure that we get all of this working. We're going to place you there, we're going to do that, and we're going to run the GUI. So, Oh, my screen just cut. Ah! Screaming. My monitor does that sometimes. Not sure why. I don't like to think about it too hard. Alright. Spectral.py. Let's go. Image isn't defined. Oh no, that's right. I need to get these imports in there. And it's taipy.gui. Alright, let's give it a shot again. Can I write? So right now I'm going to convert everything to a UN8 because it does not like being a floating point number, which is reasonable. I don't like being a floating point number either. Cannot write mode F as PNG. Oh gosh. Just gonna call it the JPEG. Call it a day. Oh, and he need numpy. That's important. Okay. One moment while we look at pillow. Where'd my top bar go? The hell? Is it... What are my parameters for this? Format. Hey, it's working. All right, let's look at our beautiful image. Yep, that's what an image looks like. Multispectral images typically don't look all that great. They sometimes can, but today they won't be. But we can do more interesting things with multispectral images. So, oh. Taipy lets us do a lot with terms of graphs. So we're going to pull up some of these graphs that we can create. We want a Taipy. I would like to make a line graph. Oh boy. I don't want to throw, I just want line chart. So, okay. So, we can add stuff like this where we have data coming in. And we're creating a nice little data chart here. So we would like we want lines, we want a chart, and we want our data cube here. We want our X to be, yeah, let's do this in, we can define our data. Oops. We want our X to be the we want the velocities on the X coordinate. So let me go pull that. So cube dot not spatial coordinate map. We're now listening to fun. I'm going to change this. I don't want to listen to Christmas music. Oh boy. I want royalty-free cozy music, not royalty-free Christmas music. I'm not about that Christmas music life right now. Oh boy. Alright, well, we're just gonna do it this way. So cube shape 2 should give us that. And we're gonna call that ranges, frames. And then our second one here is going to be a nice, we're gonna take the average. All right. And we'll have some fun with it. We'll take the average, we'll do the mean, or the max, and we'll do the min value. Sure. So let's take a look at what we got now. It's probably yelling at me for something. Oh, I don't need length in here. I just need cube shape. Whoopsies. Let's delete that. Oh. I don't think it likes me doing maxes that way, because it probably wants me to do, like... Yeah, it wants me to do max. Dot max. Not max. Instead of NP average. Or mean. Alright. What are all my squigglies here? What is it mad at me about now? Is it because they have extra parentheses, probably? Yeah, probably. That's it. Okay. Now we give this a try. Boom, 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 boom. It's loading things up. And we're now going to get a nice, clean graph that is not graphing properly. We should be having a nice graph here. Why don't we inspect and see what sort of data we're actually getting out of this thing? Oh. does not like being sliced like that, which is not fun. So it's because these things have units that gets confusing. So if I just do... Ugh. It's 2 value. Okay. Let's try this again. Dot 2 value. So what the issue right now is these things have units, and it does not like serializing things that have units. So let's try this again. There we go. Now we can actually see the values of these from 0 to 256, which is, or from, that's right, I forgot it has negative values sometimes too. You can make nice graphs like this, zoom in and out of them, and build analysis tools for your data. This is pretty much around the end of where I want it to be. I wanted to make a tool that you can see the image in here, and then also view some of the data from that image. Another thing that I was going to have is maybe have a file upload, which would just be using the file selector, where you just define a little file selector here in the markdown and say, like, I want to be able to create something that loads up these things. On action, it will run this, and that might be where it generates the image, loads the image, all that sort of stuff. And this is just kind of like a basic tutorial on getting started with all of that. In the meantime, I'm just going to start playing with, I'd be finding some different files, but if you have any questions for me, feel free to ask them in chat. Like I said earlier, I'm a grad student working at NASA, so I have lots of knowledge about lots of weird space things, so feel free to ask away. If you don't have any other questions, though, I might just play around with Taipy and see what other fun things I can do. Maybe I'll do this file selector. Doesn't seem all that hard to do. So now we have a file selector. Select file, lets you pick files from your computer. There is no, I need to find the function name. Fascinating. I wonder what other things are in the charting library. Line charts. Because I know that it's pretty extensive what you can do with the line charts. Line, bubble, candlestick, funnel, Gantt charts, pie charts, polar charts. It's a polar chart. Oh, you can make little polar. That's actually really useful for certain things. I'm actually kind of curious how this plays out. Well, nah, I don't want to mess this all up. Well, what I'm going to do here is I'm going to start wrapping things up by loading all of this into a repo, so that way you can start playing with it. We don't need the notebook anymore. Probably need the requirements. I'll save that, sure. Main.css probably doesn't matter. But yeah, I'm just going to clean up some of the code here, so that way I can easily move this on over to work with all y'all. Alrighty. But thanks for sticking with me. Sorry for the getting the spectral cube being a little scuffed. I thought I had that file on this computer. I think it's sitting on a server somewhere. But yeah, let's make a little repo. Initialize a repository. Let's not commit that file, but commit the rest of these. I'm not going to commit the Mastcam files, but I will note where to find them. Let's make a new .git ignore. Ignore all my Mastcam files. And while we're at it, .ds store. Thank you, Mac, for giving me weird files. And probably... And I'm not going to commit these notebooks as well. All right. Oh. All right. Okay. Save all and commit changes. Let's. All right. We're gonna publish this branch to a new public repo. Alrighty, and it should be on my GitHub. It's me. It's a very old photo of me. Alright, and now we're gonna be good here. And, oh, I'm not signed in. Let's do it this way. Oh, I'm also not signed in here. Okay, whatever. It's fine. Add a readme. Taipy. Example, Taipy projects. We're gonna go. That uses the bowl plate on Curiosity Rovers Mastcam. And I'm going to put a link to that data set here in case you are curious about it. Synodo records. to show awesome Mars photos and display. Show an example of how to render NumPy data. And then finally, we have spectral.py, example project to get started working with astronomical data and making graphs based on data sets. All right, cool. Commit changes, commit the changes to that. All right, awesome. Well, thank y'all for coming. I'll put a link to this in chat in case you are curious and you want to try branching out and using any of the data. I will also grab a link to the check-in, so make sure to check in to get points and get points for attending this event. So 1 moment. And if you are looking for this repo after the fact, please, please, please feel free, and I'll put it in the repo link here. I'll chuck a repo link in the announcement that I made on the Discord server. All right, well, thank you. I still have a little bit of time, so if you have any other questions for me, feel free to ask. But otherwise, I'm just gonna hang out here for a bit. Then I'm gonna go hang out with my cat. Anyone have any fun plans for the rest of their day? Or maybe it's the end of your day and you're going to bed. I don't know what time zones are. For me, it's only like 2 o'clock. My coffee's cold. All right, well, on that note, it was great working with you. I hope you use Taipy in the future. I unironically will probably end this session and then go continue working on the stuff that I need to do for my research. But yeah, it was great chatting with y'all. And I hope you all have a wonderful rest of the holiday season. And catch you again on a future stream. See ya.